Now we shall discuss some important integrals, or I call them a special function. For example, of this kind, 1 upon a sin x plus b cos x plus c, or integral 1 upon a sin x plus b, or integral 1 upon a cos x plus b. What you notice here is the numerator is only 1 and denominator is combination of sin and cos. And in such type of problem, what you need to do is, we need to write sin x in terms of tan x by 2. So 2 tan x by 2 upon 1 plus tan square x by 2. You will notice that the denominator is x square x by 2, which is the derivative of tan x by 2. So if you convert sin x and cos x to tan x by 2, automatically the derivative is present, which is when you substitute here, it will be in the denominator, it will go to the numerator, and this 1 plus tan square x by 2 will turn to sec square x by 2, which is the derivative of tan x by 2. This is the trick that need to be followed. So I'll teach you some questions based on this. Let's say integral 1 upon 2 plus 3 sin x plus cos x. So I am going to put tan x by 2 as t. Naturally, I need to change dx to dt. So I do this way. I write it as tan inverse t. So dx will become 2 into this 2 get cross multiplied, 1 upon 1 plus t square into dt. Then sin x can be replaced by 2 tan x by 2 upon 1 plus tan square x by 2. So that becomes 2t upon 1 plus t square. Cos x can be replaced by 1 minus tan square x by 2 upon 1 plus tan square x by 2. That became 1 minus t square upon 1 plus t square. So this integral became, denominator will be 2 will remain as it is, 3 into 2t upon 1 plus t square. Cos x will be 1 minus t square upon 1 plus t square. So we have picked up, in place of sin x we replace 2t upon 1 plus t square, in place of cos x we replace 1 minus t square upon 1 plus t square. In place of dx, I will write 2 dt upon 1 plus t square. So 1 plus t square will get cancelled. So you will be getting 2 dt upon 2 into 1 plus t square plus 6t plus 1 minus t square. So this will become 2 dt upon t square plus 6t plus 3. 2 plus 1, 3. Now we can complete the square. So this will become 2 goes outside. 1 plus t plus 3 the whole square, that is 9 minus 6. I completed the square. T square plus 60 added 9, subtracted 9. That became 2 into 1 by 2a log of t plus 3 minus root 6, t plus 3 plus root 6. This 2 and this 2 will get cancelled. Now where there is t, we can replace it by tan x by 2. So 1 by root 6 log of tan x by 2 plus 3 minus root 6 divided by tan x by 2 plus 3 plus root 6. This becomes your answer. So whenever we have denominator sin and cos combination, it may be only sin with a constant, only cos with a constant, we need to do this procedure. Actually, frankly speaking, we are converting everything to tan x by 2. So the derivative, this denominator 1 plus tan square x by 2 goes to numerator. That becomes the derivative, and we can do the problem by substituting tan x by 2 as t. But what is the benefit of writing in this manner is, we don't have to keep on converting. You can directly replace. Put tan x by 2 as t. Dx you directly write. Sin x directly write. Cos x you directly. You don't have to write all these steps every time. you need to just directly replace it and write the answer. So you can calculate it faster by keeping this tan x by 2 as t. Next is integral 1 upon 3 plus 5 cos x. So again we can see that numerator is 1, denominator is a combination of cos and a constant. So your method is put tan x by 2 is equal to t. So directly you can make x as a subject, differentiate it 2 dt upon 1 plus t square into dt. Directly you can write. In place of cos x, I can write directly 1 minus t square upon 1 plus t square. It is not necessary for me to write the formula. Now you can replace it. So the integral I will become 2 dt upon 1 plus t square in place of dx. Become 3 plus 5 into 1 minus t square upon 1 plus t square. Now what we can do, we can take the LCM. When you take the LCM, numerator will be 2 dt. Denominator will be 3 into 1 plus t square plus 5 into 1 minus t square. So we don't have to, denominator LCM get cancelled, so we don't have to write all the steps. You can just directly write the answers. So 2 goes outside, integral 1 upon 3t square minus 5t square, so 8 minus 2t square. You can take a 2 common and cancel it off. So 1 upon 4 minus t square dt. Now you can apply the formula 1 by 2a log of 2 plus t upon 2 minus t plus c. Now t can be replaced by tan x by 2 and that becomes your final answer. That becomes your final answer. This is how we can complete this problem. One more problem let's do by using this method. Integral 1 upon 1 minus 2 sin x dx. So again, put tan x by 2 as t. Whenever the denominator has a sin x and a constant, numerator should be 1. You will put tan x by 2 as t. So I can write x equal to 2 tan inverse t. So dx became 2 upon 1 plus t square dt. And sin x can be written as 2t upon 1 plus t square by the formula. Sin x is sin 2 theta's formula, 2 tan theta upon, actually which formula are we applying here? Sin 2 theta is 2 tan theta upon 1 plus tan square theta. So naturally sin x will be 2 tan x by 2 upon 1 plus tan square x by 2. If at all you have not understood this, I am writing it this again. But in the exam, directly write this. You don't have to write all the steps. Now you can write the integral I as 2 dt upon 1 plus t square will be numerator. Denominator will be 1 minus 2 into 2t upon 1 plus t square. Now I can write the integral as 2 upon, now tell me LCM 1 plus t square. So 1 plus t square minus 4t. The 1 plus t square and denominator 1 plus t square get cancelled. So let me complete the square. T square minus 4t plus 1, of course dt. Now completing the square, 2 integral 1 upon t minus 2 the whole square plus 4. I added 4, subtracted 4, so minus 3. So I can write now 2 into 1 by 2 root 3 log of t minus 2 minus root 3 upon t minus 2 plus root 3. So my answer became 1 by root 3 log of tan x by 2 minus root 3 upon tan x by 2 minus 2 plus root 3. This is the final answer. This problem is slightly different. Remember, this cos alpha is a constant because the variable of differentiation integration is x. So this will be treated as a constant. So let's proceed with the same method. This is a constant plus cos x. So there is no change in the method. So you will be putting tan x by 2 as t. So dx become 2 dt upon 1 plus t square, and cos x will be replaced by 1 minus t square upon 1 plus t square. But remember, cos alpha is a constant, it will remain as it is. So this became 2 dt upon 1 plus t square. This is what I replace instead of dx. So cos alpha will remain as it is, 1 minus t square upon 1 plus t square. Now we'll take the LCM as usual. So there's no change in the method. 1 plus t square into cos alpha plus 1 minus t square into dt. Now the t square's coefficients are, okay, I'll put the 2 also. Cos alpha minus 1 into t square and cos alpha plus 1. Now I purposely wrote in this manner to make you understand. Cos alpha minus 1 is a negative number because cos alpha's maximum value is 1. To make it positive, I will take a minus common here. I'll write as minus 1 minus cos alpha into t square. Now this became positive, and here I'll write 1 plus cos alpha. This is a step most important to us. Now we will replace this by a perfect square. You know the formula for 1 minus cos theta and 1 plus cos theta. So I'll put those formulae. Minus 2 sine square alpha by 2 into t square plus 2 cos square alpha by 2 into dt. Now this 2 can be cancelled off. Now I can write 1 over constant first and sine alpha by 2 into t second dt. This is like a square minus x square. So I can, this is similar to dx upon a square minus x square. 1 by 2a log of a plus x upon a minus x. So you every time you remember this, coefficient of t square should be positive. To make it positive, I took a minus common. Now sine square alpha by 2 became a positive number and the negative minus came here, so it can be compared with this formula. If I had kept it like this, it was difficult for me to understand that this is a negative number. Then the formula would change to a square plus x square, and you are likely to make a mistake there. That is the reason why we need to make it into perfect square here. So now I can write the formula as 1 by 2 cos alpha by 2. T as a coefficient, so I am writing that also now. This sine alpha by 2 came as t's coefficient. Log of cos alpha by 2 plus sine alpha by 2 into t divided by cos alpha by 2 minus sine alpha by 2 into t plus c, which I can write as 1 upon sine alpha into log of, divide numerator and denominator by sine alpha by 2. So it became cot alpha by 2 plus t became tan x by 2. This t is replaced by tan x by 2 divided by sine alpha by 2. So cot alpha by 2 minus tan x by 2. This you are writing in this manner so that your answer looks better. If you want, you can write this as 1 upon sine alpha is cosec. Which formula did I apply here? 2 sine theta cos theta is sine 2 theta. That formula I applied. This is cos, but this is cot. How it became cot? I divided numerator and denominator by sine alpha by 2, so that the answer looks a little more better. Now the change is only angles are doubled. Previously we had a sin x plus b cos x, but now angle is 2x here. So you need to notice this. The angles are doubled. Everywhere the angle is doubled. In such case, only difference is your substitution also angle will get doubled. Previously your substitution was tan x by 2 is equal to t. So now the change will be, you will need to put tan x as 2, because we will be able to express sin 2x only in terms of tan x. You can write sin 2x as only as 2 tan x upon 1 plus tan square x by 2. Previously when we had sin x, we wrote it as 2 tan x by 2 upon 1 plus tan square x by 2. So if the angle is 2x, substitution is tan x. If the angle is x, substitution is x by 2. So that's all the difference that we have. So we will be putting tan x as t. So now our substitution became x equal to tan inverse t. So dx became 1 upon 1 plus t square into dt. So in place of cos 2x, I can write 1 minus t square upon 1 plus t square, because cos 2x formula, what is cos 2x formula? Cos 2x is 1 minus tan square x upon 1 plus tan square x. So I can write cos 2x as 1 minus t square upon 1 plus t square. So the problem remains in the same manner. So the integral I became 1 dx I can write as 1 upon 1 plus t square into dt divided by 3 minus 2 into, in place of cos 2x I can write 1 minus t square upon 1 plus t square. So when you take the LCM, 1 over 3 into 1 plus t square minus 2 into 1 minus t square. This became 3t square plus t square, so 1 upon 5t square plus 1 into dt. 3 minus 2 gives you 1. So I can write now this as 1 upon root 5t the whole square plus 1 square dt. So which formula can I apply here? The formula that I need to apply here is dx upon x square plus a square is 1 by a tan inverse x by a. I need to apply this formula. So my answer became 1 by a. So 1 by a is 1, but t is having a coefficient, so they have to divide by t is coefficient, tan inverse root 5t upon 1 plus c. So my final answer 1 by root 5 tan inverse root 5 tan x plus c. This is the answer that you will be having. Next one is integral cos x minus sin x divided by root of 8 plus sin 2x. This is a special method, different from whatever we have done till now. The method that we are adopting is, we ask the question whose derivative is the numerator. In fact, I am asking what is the integral of cos x minus sin x. What is the integral of cos x minus sin x? Integral of cos x is sin x. Integral of minus sin x is plus cos x. So I can say now, if I put sin x plus cos x as t, its derivative is present. So I am allowed to put sin x plus cos x as t. I have the permission to do that because the derivative is present. But only my problem is, will I be able to convert the denominator also into t? This is only the problem. So what I do is, anyhow, let me write the first step. Sin x plus cos x is t. Its derivative cos x minus sin x into dx becomes dt. Then I will square this. Sin x plus cos x the whole square became t square. For what purpose I am squaring? To convert this also into t. When you expand this, sin square theta plus cos square theta is 1. 2 sin x cos x becomes t square. That became sin 2x is t square minus 1. This is sin 2x. The 1 came to left hand side. So now my integral became, whole numerator became dt. The denominator became 8 plus t square minus 1. That became integral 1 upon root of t square plus 7 into dt. That is log of t plus root of t square plus 7 plus c. Now replacing t back, log of what t stands for, sin x plus cos x. So sin x plus cos x plus root of sin x plus cos x the whole square plus 7 plus t. Instead of this, you may write in terms of sin 2x. Sin x plus cos x the whole square can be written as 1 minus 1 plus sin 2x, and you can make it into sin 2x if you feel like. So if you feel like, you can write like this, sin x plus cos x here. When you expand this, it becomes 1 plus sin 2x, so 8 plus sin 2x. I've added the 7 also with that 1 plus c. You can write it this way or this way, however you feel like. Another problem of the same kind is x square plus 1 upon x raised to 4 plus 1. What you do is divide numerator and denominator by x square. If you divide numerator and denominator by x square, this will turn to 1 plus 1 by x square. If you divide this by x square, it became x square. Divide this by x square, so 1 by x square. So divided numerator and denominator by x square. After that, you will notice that what is the derivative of a function which will give you 1 plus 1 by x square as the answer. Naturally, integral of 1, that become x. Integral of 1 by x square, that is 1 minus 1 by x. Right? X raised to minus 2 upon. So if I integrate, if I differentiate 1 by x square, I'll get minus 1 by x, I'll get 1 by x square. So I can put, I'm allowed to put x minus 1 by x as t. So I am putting whosoever integral of the numerator, I should say that the integral of the numerator is put as t, so that the derivative becomes its dx becomes its dt. Now the only thing is I need to express this also in terms of t. So like last time, I'll square it. X minus 1 by x the whole square is t square. So x square minus 2 plus 1 by x square equal to t square. 2ab terms becomes only 2. So in place of x square plus 1 by x square, I can write t square plus 2. So the numerator became 1 plus 1 by x square became dt. X square plus 1 by x square became t square plus 2. So I can write this as 1 by a tan inverse t by root 2 plus c. That is 1 by root 2 tan inverse. In place of t, I can replace x minus 1 by x upon root 2 plus c. You may take an LCM here. 1 by root 2 tan inverse of x square minus 1 upon root 2x plus c. Usually this method is applied when numerator is a quadratic. In numerator is x square plus a constant, and denominator is x raised to 4 and x square terms are there. Then also you can apply this method. Another special case, integral root of 1 plus sec x. So this you can write root of 1 plus 1 by cos x. Now if you take LCM, root of 1 plus cos x upon root cos x. Now 1 plus cos x you have seen, so it becomes root of 2 cos square x by 2 into root cos x. That root 2 came outside the integral, cos x by 2. Now cos x by 2 is the derivative of sine. So cos 2 theta can be written in different ways. So one of the cos 2 theta's formula is 1 minus 2 sine square theta, and one of the formula is 2 cos square theta minus 1. So if I write in terms of sine, then its derivative is present. So this cos x will be written as root of 1 minus 2 sine square x by 2. Sine square x by 2. So that the derivative of sine x by 2 is present here. Now I am in a position to put sine x by 2 as t, denominator is quadratic in sine x by 2 and numerator is derivative. So I can replace the sine x by 2 as t and do the problem. So I can write sine x by 2 is equal to t. So cos x by 2 into 1 by 2 is dt by dx. So cos x by 2 dx is 2 dt. So my integral became now root 2 integral 2 dt divided by root of 1 minus 2 t square. So I can now write this as 2 root 2 integral 1 upon root of 1 minus root t the whole square into dt. This became 2 root 2 sine inverse root 2t sine inverse x by a upon coefficient of x plus c. Which formula did I apply? Dx upon root of a square minus x square is sine inverse x upon a. Here a is 1. A is 1, so nothing is written here. So my final answer is 2 sine inverse root. Now t stands for sine x by 2 plus c. This becomes my final answer. This is the way we can solve this problem.